When you go to make breakfast, you don't even think about it, right? It's just automatic. But for an AI, that same simple task is one of the biggest, toughest problems in the entire field. We're talking about how to solve complex, multi-step problems. And this isn't some small thing, it's a massive challenge for basically every kind of AI out there. So today, we're going to dig into a really cool new framework that's trying to teach AI to plan a lot more like a human.
All right, here's the game plan for today. We're going to kick things off with a super relatable problem, a robot in a kitchen. From there, we'll look at this wild idea of using language as a kind of blueprint. Then we'll get into the nitty-gritty of this new framework called ADA and really unpack what makes it so different, its secret sauce, if you will. After that, we'll see it in action with some mind-blowing results from Minecraft and household chores. And finally, we'll zoom out and talk about what all of this means for the future of AI.
Okay, so let's get right into it. To really get why this new stuff is such a big deal, you first have to understand the problem it's trying to solve. And it's a simple question, really. Why are tasks that are a total breeze for us just unbelievably hard for even the smartest AI?
So let's go back to that breakfast idea. Think about it. When you decide, I'm going to make an omelet, you don't just do make omelet as one single step, right? No way. Your brain instantly breaks it down. You got to walk to the fridge, open it, get the eggs, grab a pan, turn on the stove, crack the eggs. I mean, it's this whole long chain of tiny little actions, all stemming from that one big goal.
Right, exactly. And that's the key. We humans are masters of creating these hierarchical plans. We take a huge goal and we just naturally chop it up into smaller bite-sized pieces. It's totally second nature for us. But for AI, this has been a huge, huge roadblock. They just aren't good at breaking things down like that. So for years, the only real solution was just brute force. You'd have human experts who would literally sit there and hand code every single rule, every single step for every new thing you wanted the AI to do. You want a robot to build a car? Great. A team of engineers will spend months programming that. Now you want that same robot to make you a cup of coffee? Welp, that's a whole new programming job from scratch. You can see why it doesn't scale at all.
So, okay, if hand coding everything is a total dead end, then what's the move? Well, this is where a really powerful no idea comes into play. What if the AI could just learn to make these plans by itself?
And this is where things get really interesting, because this is where large language models, LLMs, enter the picture. These models have basically read the entire internet, so they have this incredible amount of general knowledge about how the world works. And the big idea here, the real breakthrough, is to use an LLM not to spit out a single rigid plan, but to give the AI a foundation of common sense, sort of a general understanding it can use to figure out the steps on its own. And that's what brings us to the star of the show today. It's a framework built to do exactly this, and it's called ADA, which stands for Action Domain Acquisition.
Okay, so what is ADA? At its core, it's a framework that taps into that general knowledge from an LLM to build a library of skills. And the most important part of that sentence is interactively learns a library. The analogy I love is this. Most other methods are like asking for a single recipe for one specific dish. ADA is different. It's learning to write an entire cookbook of skills that it can mix and match later to make pretty much anything.
So, how does it build this cookbook? It all happens in this really clever 3-step loop. Step 1 is propose. The LLM looks at a goal, say, get a hot egg, and suggests a high-level skill, something general, like heat an object. Okay, step 2 is plan. A classic logical planner takes that new heat an object skill and tries to fit it into a step-by-step plan. And then the most important part, step 3, verify. The AI actually goes and tries the plan out in a simulation. Does this heat an object thing actually work? If the answer is yes, great, it gets added to the cookbook. If it fails, it gets tossed out. Simple as that.
And this cycle, this loop of proposing, planning, and then verifying, that's what makes this so powerful. It's taking the common sense ideas from the language model and then grounding them in reality through trial and error. So over time, it's not just making one-off plans. It's building up this library, this cookbook of skills that it absolutely knows for a fact work in its world.
Okay, so you might be thinking, lots of people are using LLMs for planning. What's the big deal here? And that's a great question. The
the secret sauce, the real novelty, is all about what it's learning, not just that it's learning. And this is really the key difference. Most other approaches, they just ask the LM to spit out one super long step-by-step plan. The problem, if there's even one tiny mistake in that long chain of commands, the whole thing just falls apart. Game over. But Ada's approach is totally different. It's not learning one long plan, it's learning a bunch of small, reliable, reusable skills. Think of them like Lego bricks. Once you have a bunch of verified Lego bricks, you can snap them together in all sorts of new ways to build things you've never built before. It's just way more flexible and way more robust.
Okay, the theory sounds fantastic, right? But the billion-dollar question is, does it actually work? Well, the researchers put Ada through its paces in a couple of really tough virtual environments to find out.
First up, they threw it into mini Minecraft, a world where you need to do a lot of long-term planning, gather materials, craft tools, the whole shebang. And the second test bed was a simulator called Alfred, which is basically a virtual house where the AI has to do normal household chores, heating up food, chopping veggies, cleaning up. So you've got two completely different worlds, but both are super complex in their own ways.
And the results? Well, honestly, they were pretty staggering. Ada didn't just do a little better than other advanced methods. It was in a completely different league. We're talking a 100% success rate in mini Minecraft, and in the household simulator, it hit 79%. Now, compare that to the other approaches. They were barely breaking double digits, or were even stuck in the single digits. It's not even close. It's a night and day difference. But here's the kicker, the part that's truly mind-blowing. In the Minecraft test, they specifically wanted to see if Ada could generalize. So they let it learn a bunch of basic skills on simple tasks. Then, they hit it with completely new, way more complex goals. Goals that required it to combine those basic skills in totally new ways. And, get this, without any more training, it achieved a perfect 100% success rate. I mean, that's the ultimate proof that learning this reusable library of skills is the right way to go.
Okay, so let's zoom out. What's the big takeaway from all this? What does it all mean?
What we're seeing with Ada is this incredible fusion, right? It's taking the massive common sense knowledge of an LLM and marrying it with the rock-solid logic of a classic AI planner. The focus shifts from making one-off plans to building a reusable, verified library of skills. And that library, that cookbook of actions, is what unlocks the holy grail, generalization. It's what lets an AI tackle brand new, complex problems just by using the building blocks it already knows. Now look, this doesn't mean the problem is completely solved. Of course not. But this is a massive step forward in a super exciting direction. It gets us that much closer to a future where AI agents are way more capable, way more adaptable, where they can tackle new problems in the real world, not because a human programmed them for it, but because they actually learned how to figure things out for themselves.